I might as well just double check these off. So what fresh hell is this? Hello Internet, my name is Quentin and this is Blondihacks. I'm back on the big steam engine project today. I'm going to make the connecting rod. Now, some parts go better than others, and this one did not go great. I made a lot of mistakes. I think I ended up with a usable part, but it doesn't look great, and well, maybe you can learn from the mistakes that I made. So let's go. Here's the casting from the kit for this connecting rod. It's bronze, or I guess the Brits might call this gunmetal? I don't know. The Brits have declared one particular alloy of bronze to be gunmetal, and I've never figured out which one it is. As you can see though, it's a full thousandth of a furlong in length, so even the small parts on this engine are big. It's a beautiful casting. It does have some hefty sprue chunks there that I'm going to need to remove, so I'll start by chopping off the worst of it here on the bandsaw. The bronze parts in these kits are always especially nice. These are really, really beautiful castings. They need very little work. After the bandsaw, a little bit of fettling with the Dremel there is all that's needed to bring these roughly into shape. I'll do a little more work on these later, but I need to get them in the ballpark so we can start setting up this casting for machining. It's helpful if you can get the casting to be roughly round in the places where it's supposed to be round at this stage, because there's going to be some eyeballing of things here shortly, and it's easier to do if the casting is a reasonable shape. I'm going to start once again by doing casting layout, which I'm trying to do better at with these engine kits. Some layout fluid on all of the relevant areas, and I'm going to set it up here on the surface plate with a V-block and a U-clamp there to kind of hold it in place. So I'm using a square to get the smooth side of one of the bearing caps there vertical. And I want to start by getting some kind of decent center lines here on these bosses. So I'm measuring the height of the top of the boss, and then I subtract half the width of the boss and move down and scribe that center line. Now what I'm aiming for here are center lines on each boss, but note that I did not make any attempt to level the casting here. So that shaft could be tapered, so the bosses might be at different heights on the surface plate, but it doesn't matter. I'm marking centers on each of them, and those are going to be starting points for future machining. Now the small boss here at the other end is the critical one, because this is the reference bore for the rest of the features on this part. So I'm doing my best to get a good center punch there on the center of my scribe line, and well, I kind of botched that, and I had to punch it at an angle and try to move it and then try to clean it up with a 60-degree punch, and well, it's kind of a mess, but more on that later. To complete the center at the other end, I want to reference the distance from the punch mark on the small end there, my reference end. I don't have a divider long enough to do this, so I had to use my large calipers here, which I always get comments on whenever I do that, but sometimes there is no choice. Next, to mark the bolts that go into the strap here at this end, I'm getting the casting level here with a tri-square and a 1, 2, 3 block so that I can scribe a common center line across both of these bosses that will be at the same height. And then again, I find the top and subtract half the height and move down that amount on the height gauge and scribe my center lines there. And then the same process on the vertical axis. For the verticals, I know the distance between these two bolt holes, so I'm just going back and forth with a couple of different heights until I find one where I've got two positions that are an inch apart on the height gauge, but also look visually centered on the two bosses. It doesn't matter a whole lot where these bolts land. It is aesthetic as long as they're the correct distance apart and they're not going to impinge on the bore there in the middle. To double check that spacing, I set my dividers here at the 1-inch spacing that I need, and I just double checked that my punch marks are the correct distance there. And in hindsight, I could have just used the dividers to mark these two holes like that. To drill those bolt holes, it would be nice to set it up vertically in the mill, but with the drill chuck installed, I will not have enough height here. I mean, I might be able to just barely do it, but let's do it a more interesting way. You know what machine I have with a lot of room on it? The lathe. Yeah, let's do this on the lathe. That's going to mean fixturing this on the cross slide, or I could fixture it on the tool post. Yeah, let's get crazy. Conveniently, this casting fits perfectly in one of my tool holders. And the great thing about using a tool holder for fixturing when you can is that they have this built-in height adjustment. So it's quite easy to get the part aligned vertically this way, as long as you're kind of in the ballpark already. And of course, the cross slide is for horizontal adjustment. Unfortunately, I actually need the casting to go in this way. And in this direction, it doesn't fit. Casting is slightly bigger in this dimension. So let's make it fit. I'm going to enlarge this tool holder a bit, but I need to know if it's machinable first, so I want to check the hardness of it. To do that, I have the PTC Instruments Hardness Testing Kit here. Now, every time I show this tool, people balk at the cost, but as soon as you're getting into hardness testers, you're into the world of high-end metrology and metallurgy, and those tools are expensive. So by that standard, this is actually a really affordable way to get into it. Hardness testing files are also another option, but this is a really beautiful tool and a little more accurate and foolproof than the files are. The way it works is there's a calibrated punch, and you make a mark on a clean flat piece of the material, and then you put the scope on top, and the scope has a scale in it that tells you the hardness based on how big the punch mark is. And as expected, this is reading dead soft, so we should have no trouble machining this. I want to mill the bottom of this tool holder, but not the back of it. So I'm using a feeler gauge there to get the cutter set exactly on that surface there so that the cutter will skate across it, but without cutting into it. All right, let's see if my hardness test was correct and start machining this thing. It seems to be machining well. It's making really beautiful chips, but boy, this stuff is tough. There is a lot of heat coming off of that. I can feel it in the machine, and the cutting oil is smoking off very fast. So at the very least, this is very tough steel. Right there on my second pass, you hear that change in the noise? That's where I dulled the cutter. It may be that the cutter was on the verge of dull anyway, which is why this was cutting so tough, but yeah, that was it for this cutter. I was hoping to get one more pass, but I don't think I want to push my luck here, but luckily that was just enough. I got a really beautiful finish on that. It may not have been as soft as I thought. Looking back at my test there, really you're supposed to be testing on clean bare metal, and there is some kind of coating on this tool holder, so it may well be that I measured the hardness of the coating and not the actual steel. And that was a carbide cutter, so it might have been a little bit hardened, and I cut it anyway, so who knows? Maybe I accidentally just did my first hard milling. I'll start by squaring up the tool post so that my fixture is at least square. Now let's get this casting in here. I've got some thin shim stock there to protect the casting from the set screws, and I'll set those down kind of loosely because I need to do a lot of squaring and straightening and things of the casting. I'll start with this top surface here, once again using my square on the cross slide there and a 1-2-3 block to get the casting horizontal in the lathe. Then I'll get the height in the ballpark using the adjuster on the tool holder there. Now I need to get it straight in the XZ plane, so for that I'm going to put a drill in the chuck, and I'm just using that as a visual reference along the sides of the casting there. Those sides are pretty straight and they'll be close enough for this. So you can see me tapping the back end of the casting there just to get the drill aligned visually with the sides of the bosses there. Next, the center drill goes in the chuck, and I'm going to get aligned on my first punch mark there. The only dimension left to adjust should be the height of the casting, so I'm adjusting the tool holder once again, a little spin by hand to make sure that my center drill is on my punch mark there, and then I'm just double checking by translating over the spacing of the two and making sure that the other one is aligned as well. That will verify that the casting is horizontal relative to the lathe there, and it looks like it is. So I think we are ready to go. Now the key here is I'm feeding towards me to get to the first punch mark. That's critical to get the backlash on the correct side of my eventual translation to the other hole. So I'm moving towards me to get aligned on that punch, and then once I'm in position, I carefully zero the hand wheel right there, and then I lock the cross slide down to make sure nothing moves. From here, it's just like drilling on a drill press or a mill. It's center drill, pilot drill, etc. It's just kind of cool to be feeding a drill with the carriage like this. One of the cool things about the lathe is that you get to kind of play with what's stationary and what's spinning in every situation. And sometimes the answer is not what you expect. Starting with the tapping drill size for the bolts, and this goes all the way through. This is of course eventually going to be a two-piece strap, so if you haven't seen this before, the way you do these is you drill and tap the holes for the strap first, then you can split the casting, bolt it back together, and finish your machining, and then everything is going to be correctly machined in its final resting position. So after the tapping drill size, I go up to the clearance drill size for the bolts, but these only go halfway down, which I achieve by setting an indicator on the carriage here. Trouble afoot though on the clearance drill. You can see it deflecting there as it touches the previously drilled hole. Something is no good there. Yeah, so it's fouling on the curved arch part of the casting there. So I'm going to have to switch out to an end mill and spot face this before I can do that hole. Otherwise that drill is going to cut over size and wander off course. You could, of course, spot face before doing any of these operations, but I tend to try to spot face at the end on a casting if I can, just because then you don't have to worry about your spot faces all being the exact right depth. Okay, take 2. No more fouling on that casting, and now we get a nice, clean, straight clearance hole. Now to tap the bottom half of that hole, I got my spring-loaded tap follower in the chuck, and I will tap it thusly. Once again, it's sort of funny to be working backwards on everything in the lathe here, but you know, a spindle is a spindle. Don't ever forget that. Quick test fit with the bolts that come in the kit. These are slot-headed Philister head screws, which, you know, once again, I don't love, but they will be fine for mock-up. I'll probably replace those with studs and nuts or bolts at a later time. Now I can unlock the carriage and carefully do my 1-inch translation to the other hole. Once again, I've already taken up the backlash, so my hand wheel here will be an accurate measurement of that move. Of course, you could also do this with a dial indicator and not worry about backlash, or a DRO if you have such luxuries on your lathe. I will be installing a DRO on my lathe at some point. I actually have a kit waiting for it, I just haven't gotten around to it yet. And this side was drilled and tapped the same way. I can get a little more mileage out of this setup though by bringing in the slitting saw. It's mildly terrifying to put a slitting saw in the lathe, but this is going to allow me to cut that cap off in this same setup. So this is very convenient. This would be difficult to do in my mill for the same reasons that drilling the holes is difficult in my mill. I'm using a square to line up the scribe line there with the saw, and that right there was the biggest mistake I made on this part. You'll see why here in a moment. However, I proceeded to push the part through the slitting saw, and this worked really, really well. This bronze is cutting beautifully. This is a 2-inch diameter saw, and I'm running it at 250 RPM. It's very, very happy in there, using WD-40 as lubricant on there. Unfortunately, the saw is too small to go through the entire part, so I did some manipulations here to get more depth out of it. I raised the tool holder up as high as it would go to get above the arbor on the saw a little bit, and then I lowered the tool holder down as far as it would go to get under the arbor of the saw a little bit. And when I ran out of options there, I ran over to the other side using an indicator to get the carriage in exactly the same position that it was in, and ran it in from this side on center above and below the arbor as far as I could. So using all of those manipulations, I got almost all the way through the part, all the way around it. So I did pretty well there, but couldn't quite squeeze it in there. I needed a larger saw. That's okay though, I can finish this up with a fret saw. Once the parts are separated, then you can machine the mating surfaces there. However, I'm going to do some other setup here first because it's time to start creating some references on this part before I go any further. So I'm back on the surface plate, and I want to get a center line down the entire length of the connecting rod. So similar to how I did the bosses, I'm finding the center line at each end, but the difference this time is that I'm actually using the machinist jack there on the end to get the two center lines level. I want the centers of each end of the part to be at the same height, and once I've got that, then I can scribe a center line all the way down, hopefully, the center of this casting. Now that center line is going to be crucial for setting this part up in the mill here. I need it to be horizontal in the milling vise. That tool holder is not necessarily holding it level because the shank of the connecting rod might be tapered or otherwise not straight. So using that scribe line and a stack of parallels there, I can get that line horizontal. So once the center line is horizontal, then all of my machining relative to this will be nice and vertical. I'm starting at the small end here, and I'm going to drill and bore this out first. So I'm aligning my center punch there. Unfortunately, that center punch is a bit of a mess, so I didn't have a lot of luck aligning it. As you'll see, the hole ends up not super well centered. Now I'm making this feature first because this is the reference for all other features on the connecting rod. So after pilot drilling, and reaming that to final dimension, I'm going to be able to measure and otherwise use this critical bore as the reference for all other features. For the reamer though, well, trouble afoot. As is always the case on this mill, the reamers don't fit, and of course the shanks on these import reamers are always weird sizes for some reason, so I can't put them in collets. My viewers to the rescue once again. A viewer sent me this kit. It includes a precision ground R8 collet that goes in the spindle, and these tool holders that have a precision ground top surface on them. So they slide in there and they register on that collet, thus making the setup vertically repeatable. And then there's an ER collet holder in the bottom for the tool. This is basically an import clone of the Tormach tool holding system. And the great thing is, it gives me the height that I need. And being an ER collet, it's got enough wiggle room on the dimension of the shaft that I can use it for these weird reamers. That's reamed to final dimension now. My centering job on that is not awesome, but it's okay. However, there's more trouble to come from that yet, so stay tuned. While I'm here, I also milled this face flat because it's going to be a valuable square reference for that bore, which we will need for upcoming setups. But now with the DRO zeroed on that bore, since I just drilled and reamed it, I can now use the DRO to measure the distance to the other bore, which is really key. So I moved down the length of the distance between the bores plus the radius of the cutter, and, well, trouble. I should not be able to clear that surface with the cutter. I should have to mill it down to this position, and I didn't. What this means is I cut it too short with the slitting saw in the lathe. That is really unfortunate. However, I have to clean this surface up, so I went ahead and machined it and tried to take off as little material as I could. This is very unfortunate because this surface sets the center line of the bore on that part and thus the distance between the bores on the connecting rod. Just checking the damage here, and yeah, I came up 35 thou short on that dimension. So I'm going to have to try and correct for that error somewhere upstream, either in the crosshead or the piston rod. We'll see where in the mechanism is the easiest place to compensate for that. I made a note of the error on the drawing so I can come back to it later. But now I can set up the cap in the mill, get it level, and then clean up this surface. With that cleaned up, I now bolt it back in place, and now I can measure that little boss there. I want that boss to be round when we're done, so I measure it one way and the other, and I machine the difference off of the cap. In this case, I needed to take 90 thou off, and now when I bolt that cap back on, the boss is round. And that part went well. I got within a thou of roundness there, but you'll note that the split line is not in the center of that boss anymore, and that's because of the substantial error I made in that distance. Back over to the mill now. I'm using a gauge pin in the spindle to align that bore there, and that's going to get the casting level and that bore square to the table so that the other features we create will be parallel and square to that. So I'm center drilling on my center line there, checking it with the magnifier to make sure I'm well centered, and then I drill and ream this hole out to final dimension. Once again, you can see how poorly centered it is there on that casting because of the previous errors, but there's nothing we can do about it now. For the remainder of these parts, I'm bringing in my fixture plate, and I've machined the top and bottoms of these blocks parallel, and I carefully reamed holes in them the same size as the bores in the connecting rod. And what that's going to allow me to do is set it up like this on the mill table, referencing that bottom surface. So I'm clamping to that machined surface, which is square to the bore, and I'm also keeping it aligned with the bore. And I'll put a gauge pin on the back here as well, just to verify that that bore is remaining vertical, and it is. Everything slides together nicely there. I'm going to pause here and note how even worse centered the other side of that small bore is. And this is because looking back on this setup that I was doing initially, I forgot to check that the casting was horizontal in that tool holder. I got it level on the x-axis, but didn't check for level on the y. And so those bores, while well centered on one side, went a little bit crooked through the casting. Again, unfortunate mistake. Nothing I can do about it now, but that's what happened there. But with this setup now, I can machine the far side of the rod face here, and I know it's going to be very square to that bore and very parallel to the opposite face, which is key. The other important feature of this setup is that it's very, very repeatable in the vertical. And that's necessary because in order to get these faces milled down to dimension and remain centered on the casting, I need to frequently pull the part out, measure my progress, flip it over, machine the other side a little bit, and so on. So that's the value of this setup here for doing that. And then the other end was done in a very similar setup. Nearly finished now. I'm going to center punch the matching sides and ends of the cap there to keep those forever aligned correctly. You don't want to flip those parts end for end when they're machined bespoke like this. Let's do a quick test fit here on the crankshaft. The finish on that reamed hole is really nice, so, that went well. I'll bolt this guy in place and let's see how it runs. I did nail the dimension across the connecting rod quite well, so that runs in there very smoothly now, so that's good. At least something's going right on this part. But if only I was out of the woods yet. You see, the bosses at each end are different widths, and I neglected to consider that those widths should be evenly split on the center line of the entire connecting rod. I didn't really account for that in my setups. So what this means is, with some checking on the surface plate here, I determined that the delta between the side milled faces at each end is different. The bosses are effectively off-center from one another by about 20 thousandths. Once again, very unfortunate. This I think will be a little bit easier to compensate for though. The thing is, the small end of the rod is actually a clevis, and what's critical is that the center of the clevis is in line with the center of the big end of the rod. That I can do by referencing the big end when I mill the clevis. I'm setting it up in the V-block again, and I'm starting by getting the big end vertical there with a square and double checking with a tense indicator there on that bore there, using a tense indicator because of the short distance that I have to indicate on. And that indicates that the bore is horizontal, so that's good. The clevis can now be milled. Now I center find on the big end so that I'm centered on that for this feature. Then I touch off on the end of the casting for the depth. Weirdly, the drawing specifies the depth of this slot from the end of the casting and not from the bore, and the slot is not centered on the bore, so I'm not really sure how to dimension this. Presumably the slot just has a lot of leeway in it. I milled that to depth and then widened it with some side milling. Now, the drawing specifies a square bottom slot, and don't put square bottom slots in your drawings. They're a real hassle to make, but I'm going to approximate it here by plunging a small radius end mill down into the corners, using the DRO to calculate where that should go, then finish it up with side milling to approximate a square bottom. To get a true square bottomed slot, you'd have to mill it vertically, which I don't have space for, or you could file it. And the final feature on this part is a little oil hole at a funny angle here that leads into the bearing. To finish this up, I'll do a little fettling on those bosses to get them aligned. After the splitting and the milling and so on, those casting edges are always misaligned. I've got the correct size bolts in there now, and let's do one last little test run here in the frame so you can kind of see how this is going to work. And well, that seems to be running well. We won't know for sure till we get the crosshead in there, but so far I'm pleased with how it runs, if not how it looks. We mustn't waste this opportunity for learning, however, so let's do a little post-mortem. What should I have done? Well, the first big mistake, of course, was cutting it too short, and that was down to trusting my layout lines too much. I had scribed the center line of this board using this clumsy caliper method, but I knew at the time that that wasn't an accurate way to do it, and I was just giving myself a ballpark for where that's going to land. Then I forgot that it was an approximate line when I went to set up the slitting saw. I should have measured it in the lathe before making that cut, and then cut it generously large, because they give you a lot of material there in that bore. The rest of my mistakes boil down to basic setup. Instead of trying to use that small bore as my reference for everything, I should have built a fixture to hold the casting and then left the casting in that fixture for the entire operation. I had a good idea when I started doing layout with it in a V-block like that. I should have just left it in that V-block for every single cut after that. So when you're doing a part like this, I think the way to go is to make or use a fixture block of some sort to hold that part that's going to give you reference surfaces that you can rely on, and don't move that part from that fixture until you're done. So there's my final connecting rod there, and lots went wrong on this, but in the end I did end up with a functional part, I think, though I will have to compensate for the error in length there on other parts in the mechanism. Stay tuned for how and where I do that. I don't actually know yet, but I will keep you in the loop. Thank you very much for watching, and thanks to my patrons who make all of this possible, and I will see you next time.